Alright everybody, welcome back. In this video we're going to talk about writing rules from patterns. So instead of going from the pattern to the rule, we're going to look at a pattern and try and write the rule for it. We can write rules for almost any pattern, and as we get into higher levels of mathematics we even have ways that we can really write rules for any pattern. But in this course we're going to focus on writing rules for patterns that are what we call linear. Those are the patterns that have the same number added or subtracted as we move from one term to the next. And it's actually fairly simple to write a rule from a linear pattern. We need to identify two things. We need to identify the value of the common difference between the terms. What is being added or subtracted to get from one term to the next. And that is going to end up becoming the coefficient for our n. And then we need to identify the 0th term, which is the term that would come before the first term. If we extended the pattern in the other direction, what term would come right before the first term? And we're going to add that onto this. So suppose the common difference we were adding 12 to go from one term to the next, and we figured out that the 0th term would be 5. Then our rule would be that a sub n is equal to 12n plus 5. So let's do a few examples and get this under our belt here. Alright, part A. We're going to write the rule for each of the following patterns. Here we go. So the first thing I do is I look at what is the common difference to get from one term to the next in this pattern. What are we adding or subtracting always to get from one term to the next? We're always adding 4. So our common difference is going to be a positive 4. So when we go to write our rule, we're going to have a sub n is equal to 4 times n. And then what we need to do is we need to figure out what the 0th term is. What term would come before 6 in this pattern if the pattern continued in the other direction? Well, since we're adding 4 to go forward, we would subtract 4 to go backwards. So I subtract 4 from 6, and the 0th term is going to be 2. And we're going to add that on to the end. And that gives us our rule that generates this pattern. And you can double check and substitute in the numbers 1, 2, 3, 4, 5 in here for n, and make sure that it gives you the values that are actually listed in your pattern. And if you do that, you'll find that this indeed works, and that rule does generate the pattern that you see there. Alright, let's look at the next one. First, identify your common difference. What am I doing to get from one term to the next? I'm always subtracting 3. So my common difference is negative 3. And then I need to figure out what the 0th term is. What term would come before 17? And since we're subtracting 3 as we move forward in the pattern, to get that 0th term, we're going to add 3 to the first term. And so the 0th term is going to be 20. And we'll add that 20 on to the end of our rule. And there's the rule for this pattern. And again, we could double check by substituting the numbers 1, 2, 3, 4, 5 in there. And you'll see that this rule indeed does generate that pattern. Alright, let's look at the next one. What is the common difference? We're adding 3. So our common difference is positive 3. What would be the 0th term? So we take 3 away from the first term, which is 5. And that 0th term would be 2. And so we're going to add 2 on. And there's our rule for that pattern. And you see, after you do a few of these, it really becomes second nature and pretty easy to write these linear rules for these patterns. Alright, let's look at the last one. As we go from term to term, we're always subtracting 7. And the 0th term is going to be the term before 48. Well, since we were subtracting 7 when we went forward, we're going to add 7 to 48. And the term that would come before it is 55. And add that onto the end of our rule. And there's our rule for that pattern. Alright, that's how we write rules from patterns. See you guys next time.